Students, this is the preview video for lesson 2.2, segments on a coordinate plane. I have a new set of preview notes. Here's your calendar for the next month. Suggestions on how to grade this. All right, so you should be watching this on the 14th, 15th prior to class on the 16th and 17th. Don't forget to have both the location, date, and time that you're watching this video and get a parent, guardian, or teacher supervision sign off. Let's do a quick review here first. So on this page, you want to attempt to fill in all these blanks without a calculator. Do that on your own, and then restart. Pause. Welcome back. The pattern we're fishing for here is any radical times itself is just a number on the outside. So root 2 times root 2 is 2. Root 5 times root 5 is 5. This is root 3, of course. Here, I want to get to 14, so I need another root 7, because root 7 times root 7 is 7, and then 2 times 7 gives us the 14. This one, root 7 times root 7 is 7. 5 times 7 is 35. Root 3 times root 3 is 3. And then 6 times 3 is 18. Root 5 times root 5 is 5. 12 times 5 is 60. Root 2 times root 2 is 2. 3 times 2 is 6. Then these got a little bit trickier. Sometimes you have to do what you know you need. We need at least a root 6 here to get rid of the radical. Root 6 times root 6 is 6. And you ask yourself, what else do you need in order to get 12? And that would be 2. So inside this box is 2 root 6. Yes, that's actually a singular number there. And this last one is going to be 6 root 5. We're going to be seeing these frequently this semester. So if you have any trouble with these, come see me this way in tutoring face-to-face. I have what I call the 3-minute cure. We do a little exercise together, a little drill. After 3 minutes, you'll never be afraid of those radicals again, I guarantee. But I need to see you face-to-face, one-on-one in tutoring. So taking a look here, we're talking about segments on a coordinate plane. Key terms: rise, run, slope, midpoint, distance, average. Working on a coordinate plane is used in a variety of professions. Just a couple of them. Working on a coordinate plane when you're dealing with archaeologists. They make coordinates of their digs in order to document all finds. All kind of graphic computer programming requires coordinate plane manipulation, digital graphics. Obviously, any GPS and cartographer kind of map makers require the use of coordinate planes. In today's lesson, we're going to be doing 3 things with segments on a plane. 3 things. The first thing we're going to learn is how to find the measure of a segment on a plane. Measure. Actually, that's not measure, that's the third one. Excuse me there. Midpoint is the first thing. Midpoint. Length or measure goes down here. And then the tilt of a segment on the plane. So all 3 of these, finding midpoint, tilt, and length, are all different things we can do with the segment on a plane. And when we say plane, think a two-dimensional XY graph. Technically, that is a plane. Let's start with something really simple here. We have S at -8, and we have T at +2. I'd like you to find the exact middle. The exact middle. Now, there's a couple ways you can do this. We realize there's 10 units between them, and so all I need to do is count 5. 1, 2, 3, 4, and 5, and lo and behold, I have the exact middle right here, which is coordinate -3. Or you can do what's called average. Let's average. -8 plus +2. You add and you divide by the number that you have, which in this case is 2. -6 divided by 2. Lo and behold, you get -3. So the average of the two coordinates is also the coordinate of the midpoint. The average of the two coordinates is also the coordinate of the midpoint. I'd like you to box the word average, box the word midpoint. Now, a number line is only one dimension. It's just length. So when you average, to find a midpoint, you only need to average once because it's one dimension. So to find the average on a one-dimensional line between points S and T, you add and then you divide by 2. It's two coordinates, and you only do it once because it's one dimension. But a grid or plane is 2 dimensions. So in that case, you have to average twice. When you're dealing with a two-dimensional plane, it's 2 dimensions. We average twice. So when you find the average, whenever we're the next 3 equations, I always want you to do these 4 steps. 1, I want you to say the equation and write it at the same time. 2, you're going to write what's called a blank template. And a template means basically the equation. Look really careful. There's the equation. It's the equation minus all the x and y's. That's called a blank template. That's the template. This is the equation. See the difference? Make sure you understand the difference. I'm going to use those terms in class. The equation is the full equation with your x's and your y's. A template is basically the equation with the x's and the y's left blank. Then you're going to do what's called circle box, plug, chug. Circle, box, plug, chug. The midpoint formula is add the x's, divide by 2, comma, add the y's, divide by 2. Say it with me. The midpoint formula is add the x's, divide by 2, comma, add the y's, divide by 2. You want to say it and write it 3 times. I'll demonstrate for the first one. The midpoint formula is add the x's, divide by 2, comma, add the y's, divide by 2. Do that twice more. Now we're going to do an example. When using midpoint, we're going to say the equation, we're going to write the equation, we're going to write a blank template, then circle, box, plug, chug. We have a coordinate here, -5, +3, and we have 1 and -5. I'm going to find the midpoint. The midpoint equation is add the x's, divide by 2, add the y's, comma, add the y's, divide by 2. Now we're going to write a template. Template looks like this, the blank template for midpoint. There's our template. And we circle our x's and box our y's. Circle our x's, box the y's. Circle box, plug, chug. Ready? Plug it in. Add the x's, divide by 2. Add the y's, divide by 2. That's circle box, plug, chug. Now you just do your math here. And then visually plot and check. Lo and behold, yes, it looks like the midpoint. So you're going to put little hatch marks on either side to say those two pieces are equal. Again, I want you to say and write the equation, write a blank template, circle blocks, plug, chug. Do this on your own. Pause. Welcome back. So we have here -3 and 8. And then 1, -1, and +5. We write a template, which for the midpoint looks like this. Ready? Circle box, plug, chug. So we circle the x's, plug it in. Box our y's, plug them in. Clean up your math here. And then we plot. So we're at -2, and since 6½ here, there's 6½. Lo and behold, right in the middle. So that's 1, finding the midpoint of a segment. Next, we're going to find the tilt of a segment. The tilt using the slope equation. Once again, we say the equation and we write it. We use a blank template, which for slope looks like this. Subtract over, bring that subtract to the middle. And then you circle block, plug, chug. Ready? The slope formula is rise over, run, subtract the y's, over, subtract the x's. Say it and write it 3 times. Slope is rise over, run, subtract the y's, over, subtract the x's. Do it 2 more times. Say it and write. Same segment here. We're going to find our slope right here between -5 and (3). And this is 1, -5. First, we're going to do it manually. Rise over, run. So we're just going to bunny hop it here. So bunny hop with me. Or I could have gone this way. It's going to be the same thing. But what you need to know is we're going downward from left to right. So I know this is a negative slope. So it's negative. My rise is 8. My run is 6. And you reduce always as far as possible. So it's negative. 2 goes in there 4 times and 4/3. So that's the slope manually. Now we're going to find the slope algebraically. You start by writing the slope templates. We write slope equals, and that is a slope template. I cannot emphasize enough how important it is to start with a blank template. That is a slope template. Always write a blank template before you plug stuff in. Remember 15 years of teaching the same subject? There's a reason. Blank templates. Ready? Circle box, plug, chug. We're going to start with our y's because y's go on top. So I'm going to box my y's, and I draw an arrow left to right. I'm going to be consistent in the way I go. Circle your x's. Again, I draw an arrow to keep my direction consistent. Could you have gone right to left? Absolutely. But if you start right to left, you go that way first, then you must finish that way. What's really important, it doesn't matter which direction you start with, as long as you're consistent, left to right, or right to left, right to left. Clean this up here. Double negative makes a positive. That's 8 over negative 6, and it is negative 4/3 again. You try this page on your own. Follow the template process, please. Pause. Welcome back. Let's see how you did here. Okay, so we're going to put these here. Negative 3 and 8. 1, 2, 3, and 8. Negative 1 and 5. And we're going to do our manual here. Actually, it doesn't say manual, so we're just going to start with a template. There's our template. And I like to box the y's, and I'm going to subtract left to right. 8 minus 5. Circle my x's, subtract left to right. Check your math. That's going to be 3. Double negative makes a positive. Negative 2, so it's negative 3 over 2. I can double check here. 1, 2, 3. My rise is 3. My run is 2, and it is a negative downward tilting line. So you should have gotten negative 3 over 2. This one here, 7 and negative 2, so we're positive 7, negative 2, and negative 5, positive 6. Start with the template. You subtract 1 on top, 1 on bottom. Y's, subtract the y's. What? Y's, subtract the x's. Clean it up. Double right here, that's going to be negative 8. Double negative makes a positive, that's 12. 4 goes into both of these. 4 goes in there twice. 4 goes in there 3 times. And it's still negative, so it's negative 2/3. And there is your slope. You can double check it right here by doing it manually. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. It's a negative line. So that has to be negative. It's a negative downward line. So what have we done so far? We have found the midpoint of a segment, and we have found the tilt of a segment. We have found the midpoint of a segment, and we have found the tilt of a segment. That's what we've done so far, midpoint and tilt. There's midpoint, and there's tilt. Last thing we're going to talk about is how to find the length, or measure, or distance. All of those are synonymous. So the distance equation. When using the distance equation, you say it, you write it. Then you make a blank template, which looks like this. Then you circle box, plug, chug. Here's the original distance equation. I'd like you to say this out loud. Distance is giant square root. Subtract the x's squared plus subtract the y's squared. Distance is giant square root. Subtract the x's squared plus subtract the y's squared. We're going to say it and write it 3 times. Distance is giant square root. Subtract the x's squared plus subtract the y's squared. Say it and write it 2 more times. So here's an example. This is -5, 3, and 1, -5. Ready? We write a template. Distance is going to be giant square root, subtract the x's squared, subtract the y squared. That is a blank template. Notice I left the x's and the y's completely blank. Very critical, you write a template first. Now we circle box, plug, chug. I circle my x's, I plug them in. I'm going to go left to right. I box my y's. Notice I draw an arrow to keep my eyeballs going the same direction. Plug them in. If you start left to right, finish left to right. If you decide to subtract right to left, just finish right to left. Be consistent in your direction. Now, we're going to finish this together. So we have -5 minus 1, that's -6, parentheses squared, plus 3 minus negative, double negative makes a positive. This is going to be 8 squared. And then don't drop that square root sign. Warning, the square root sign does not cancel the squares. Why? Because of that plus sign in between. So this actually looks like this. -6 times -6 plus 8 times 8. Add your own math. Once you get to the square root, if you can simplify, do so, which in this case, it's a perfect square, so it's just a big fat 10. Follow the same process. I'd like you to do these 2 on your own, then check your work. Pause. Welcome back. Let's check a look here. First thing I do is I plot my points. So I have -3 and 8. And -1, 5 again. I could tell it's kind of a short line. Now I make my template, which is distance equals Subtract the x's squared plus subtract the y squared. Circle my x's. Okay, so I circle the x's and you plug it in. And then I box my y's and plug them in. Again, I'm going left to right each time. Watch very carefully. That's going to be -3 plus 1. That's -2 squared. 8 minus 5, that's going to be 3 squared. Don't drop the square root sign. Negative times a negative is a positive. So this is 4 plus 9. And you should have gotten 4 there. Let's try this one. 1 and -3. And -1, -5. Distance equals giant square root. Subtract the x's squared. Subtract the y squared. Circle my x's. Plug them in. Box my y's. Plug it in. Double negative makes a positive here, so that's 2 squared. Double negative makes a positive, so that's going to be 2 squared. This is the square root of 8, and I can simplify it. 2 is going to come out, which is actually 2 root 2. If I ask you for exact simplified form, that's the form I want. If I ask for an approximation, which would be a decimal version, you just do square root of 8 on your calculator and take it to the second decimal place. That's 2.83, approximately 2.83, but that is an approximation. Do you see the term exact? Radical form defines exact.